bizim yeni bir çıxışçımız var, Laurentiu Juratunun. He will talk about the role of UV in water and wastewater systems. UV is one of the main methods to treat water from hazardous microorganisms, because the UV is a part of the natural sunlight and it has no negative impact on the future drinking water or treated water, but UV has a big potential to kill undesired organisms. That's why I want to give flow to our respected speaker, and he will talk about. Please go.
Yes, first of all, thank you very much, Mr. Orhan and Aqualink, for inviting me to this unique event. It's a really nice experience for us. My name is Laurentiu Juratunun, and I'm area sales manager at ULTRAAQUA UV Disinfection Systems. And here's a short introduction about us. So ULTRAAQUA was founded in 1996 by two Danish water treatment scientists. Today, we have more than 10,000 UV systems installed all over the world, and we are active in more than 120 countries. We are located in Aalborg, which is a north city in Denmark, and we also have the main production facility there. Besides that, we conduct continuous R&D studies and projects together with the Danish government as well. Besides products, we also have patented technology and validated performance. And here on this slide, you can see a few of our certifications and validations for different applications. So, for example, we have developed specific series to them also. Our main markets at the moment are aquaculture, drinking water treatment, wastewater treatment, which I will be covering mostly now, swimming pools, and industrial fluids. I would like to mention a few points about our research and development department. At the moment, we have 11 scientists and full-time laboratory employees at the headquarters, which conduct all sorts of researches, from fundamental science to product development and to tailor-made researchers. We can also do in-house multi-physical CFD simulation. We also have a full-scale piloting area for both channel systems and reactor systems. And we also have a very developed laboratory consisting of equipment that is used both for testing and research, and also for preparing the water to be filtered to the certain level that we need. A few examples of the equipment that we have is, for example, TOC analyzer, which is an analyzer to test the concentration of total organic carbon. Also, we have UV spectrophotometers that can test the water for UVC, and it can also be used to conduct experiments where we dose different chemicals in the water and then see how much it affects the UV transmittance of the water. And just another example, we also have collimated beam setups, which actually are, that both use low pressure and medium pressure lamps, where we can actually test different microorganisms, viruses, bacteria, their UV dose response, and in that way we can make sure that we apply the correct UV dose to inactivate them. I would like to talk a bit about how we develop our solutions at ULTRAAQUA. So for bigger projects, which most of the cases are the wastewater projects, we start with defining the application. As my colleagues previously have covered the topics, the wastewater can be used either discharged to a water body, which can be a river, sea, lake, or it can be reused, then to be used, for example, in irrigation, which is a very popular application at the moment to certain regions. Then the next would be to conduct a feasibility study. For example, if the end user has not done that before, we can consult and advise which kind of solution would fit best his project. Because at ULTRAAQUA we focus mainly on ultraviolet systems. So we have developed systems which use low pressure, medium pressure lamps and vacuum UV lamps. So we can look at the end user's problem and then choose the best fit system. After we decide on which solution would fit the customer best, we can conduct hydraulic CFD simulation if the product is completely new or if the project actually requires something like that. And then we can test the solution for both performance parameters and to advise on the economical parameters also. A part of this simulation also covers the UV dose requirements. It's mostly about seeing the UV intensity inside of the reactor or the channel and then making sure that it actually delivers the minimum required, which has been agreed before. And then as the last step, we have a detailed design, and also after the commercials, it's about the installation. We can agree on the installation, how it should be done, and also advise on the supervision, maintenance, and service agreements, schedules also. Yeah, I have here a video. I'm just how to start. Okay. So I think it would be easier for the translator to translate from English. So basically, the UV technology penetrates the virus or the bacteria and then modifies its DNA, and eventually that microorganism cannot reproduce anymore. And of course, after a while, it will die, and it will not be a harm anymore for the person. Some benefits of UV technology. As an example, it's very easy and reliable to apply. Most solutions related to Most solutions related to UV in general are very easy to install. It's basically a plug-and-play solution. We can also, based on the environment and the water quality, we can choose the reactor material and also the control cabinet material that does not corrode, because we offer both reactors and control panels that are made in stainless steel or plastic. UV also does not change the water chemistry after the disinfection process, and it does not use any hazardous chemicals. Therefore, it does not create also any disinfection byproducts, like, for example, other disinfection technologies can do. Also, some microorganisms that are resistant to chlorine, as an example, can be easier to remove with UV instead, UV technology. Another plus of UV is that it does not affect the odor and taste, so it can be easily used for applications, for drinking water application, or for applications that involve disinfection of certain liquids and juices also. I would like to talk a little bit about the cases that we have done and to just mention the ones that are unique in a certain way. So for example, here we had a project in Mexico. You can see here the performance requirements, the peak design flow rate, what was the UV transmittance, and also what was the main parameter to count the coliform counting at for the effluent. So in this case, it's a special project because it used to be a chlorination tank setup, and then it was fully retrofitted with UV systems instead. Another special case for us, it's a project done last year in Finland, and this is an underground facility. And these units specifically were designed to be fully flood resistant, which means that in case of malfunction of the wear gate, these units will still be operating after half an hour of being fully covered with water. Here is another case that we have done. It's a smaller size project we have done in Kosovo. And just to show that the customization of the solution can be also not related to the land banks, but it can also be related to the control cabinets. So in this case, if usually we have one control cabinet controlling a separate land bank, in this case we have combined it to be together in the same control cabinet. And besides the fact that the UV can replace other technologies, we also have projects where we replace older UV systems from other manufacturers, even if it's, for example, a different type. As in this case, it used to be horizontal UV system, and we have retrofitted with our vertically inclined systems instead. So yes, this is the solution that we have proposed to Brunei. And just to mention briefly, we have also we have units that are specifically designed for municipal wastewater treatment. And you can see here the product series is called Luft, which means low UVC systems. And I have put here two cases. The one from the left, it's actually from Taiwan. From Taipei wastewater treatment plant, and the one from the right, that's actually from China. So yes, here are some or most of our open channel systems installed worldwide in the municipal application. But if you have any questions, I can also share with you afterwards the full reference list with the systems that we have provided worldwide and in different applications. Yes, so I think that's it.
Thank you very much for a very interesting speech. I have a couple of questions. In order to kill microorganisms in Azerbaijan, Azersu chlorine, use chlorine in water against UV, and I would like to ask about cost efficiency of UV against chlorinization. How much is it expensive? This is the first question, and my second question is related to the future of UV in Azerbaijan. So we have now new institutional framework, and state water agency want to separate small municipal water treatment, want to establish municipal water treatment units in rural areas of Azerbaijan, how it would be costly for rural, let's say, water consumers. Thank you.
So the first question was how much is it compared to chlorine? Is that correct? Okay. Well, to be fairly honest, I'm not quite sure how much the electricity here in Azerbaijan costs, because that's the most important parameter to take into consideration. If we compare UV to chlorine one by one, in the beginning you have a bigger installation cost for the UV disinfection system, but then in the long term it becomes a cheaper solution. And in countries where the electricity is actually cheap, then it's a very good advantage. And the second question I forgot, sorry, could you please repeat?
It's the same, it's related to cost efficiency, because in the future there will be small-scale water treatment plants in rural areas of Azerbaijan, and how it would be cheaper for municipalities to obtain this kind of technologies. And the additional question is related to the health side effects of UV technologies.
I think in general, when you compare UV to chlorine, the main advantage is that it's easier to maintain. The UV, basically, you have to install, and then it runs as long as you have the lamps inside. And then eventually you have to replace the consumables. But it's an easier process that is done not as often as the amount of work you have to do with chlorination systems. And also the other advantage, if we just don't look at the costs, is that it's much safer for both people and the environment to disinfect the water with UV instead of chlorine. But I guess we'll need to take a specific case and then have a look and compare the chlorine to UV, because I really don't know what's the electricity prices you have here in Azerbaijan.